Okay, thank you very much. As you already heard, I will talk a little bit about shaders, and I hope that today everybody can learn a little bit about it, because this is usually a little bit tricky for artists and as well for programmers. So this is about the rough schedule. I'm not sure if we can talk about the last part. We will see, depends on the time we have remaining. Okay, so basically in Vision we have two ways of integrating how to use shaders. So with our shader editor we can create shaders for surfaces or also for skinning of characters. And as we can see, surfaces have various applications, like for models, meshes, for the terrain, or it could be also something like a post-processor. And the second way is the visual shader editor, which is usually a little bit easier to use. However, as you can see, I grayed out certain areas where you cannot use the visual shader editor. So it's a nice tool to create a prototype of a shader, but you should always consider going back to the shader editor if you want to get more serious. I just want to present some initial thoughts that everybody can understand the background of this talk. So let's assume we have a shader which just displays the texture. So this is the whole shader, the whole pixel shader code. And at some point we will find out, as we already heard in the talk before, maybe just texture is not enough. For instance, we want to also have light maps. And we can also do a little bit more sophisticated light maps which involve directional light. We call that lightmap.3. Or at some point we find out we want to also have a shader for moving objects where we could use things like the light grid. So we already have 4 different variations of actually a shader that just displays the texture. So we have to maintain the code. For instance, when we change one shader, then we have to change all 4 of these. And at some point you maybe also want to use something like normal maps. And then you maybe start thinking about, oh, my material also needs something like a specular map. So as you can see, we already have now 12 shaders which do more or less the same, just with little variations. And now you're still maybe not satisfied because you want to have some kind of transparent surfaces. And of course you need this kind of transparency for every variation. So suddenly the amount of your shaders doubles again, and now we have 24 shaders to maintain. So you can see that it's easily getting very complicated, even though you just want to display the texture. So we were thinking about a way how to maintain and manage this variety more easily. And what we created is a shader permutation system. That means we can automatically generate these variations out of a single shader. So we write one shader and get multiple at once. So we can see here our default material library. So we can see there are different techniques for the light grip, for the light map, or for the lightmap.3. And out of these, we, for instance, generate then one with the alpha test or one without the alpha test automatically. So we can add here a permutation technique. That means this technique can use input to generate multiple shaders at once. Yeah, but this is not working in the visual shader editor. As I said in the beginning, there are some limitations. So how does the engine then actually knows which shader to pick out of these different material settings? So for this we have the so-called inclusion tags. So we specify some like name tags so that the engine knows which technique refers to which shading. So we can see this here. I highlighted the inclusion tag, and here this is for this specific technique, the inclusion tags we already assigned. And as I said, we can now bring in the permutations to generate multiple shaders. And for this, we first need to define which permutations we would like to create. And we do this in the shader permutation file. This is the upper file. And for instance, I defined a variable alpha test. You can see the second variable. And in the pixel shader code, I can then use the alpha test variable with this if statement. And now I get automatically two shaders by just compiling one shader code. So one shader without the alpha test and one shader with the alpha test. Of course, this is just a simple example because you can, with one shader, generate 4 or 16 or even more shaders just with a single code file. And it's much easier just maintaining one file instead of having like 10 files which you have to update again and again. I will just briefly talk about this to save a little bit of time. What you also need to think about is for shaders which kind of registers you will use. You should let the engine know which registers are needed so that it binds these registers. But usually the default settings are fine. You should just be aware that there are these settings. And similar to this, the stream masks, you should let the engine know which kind of streams you will use. For instance, will you use the vertex colors or do you use the texture coordinates? These kind of informations need to be known by the engine. And you have two ways of doing this, picking in the UI or just specify with a keyword. And let me finish with this slide. These are the keywords you can use just to let the engine know which kind of vertex streams you can use. So this already concludes my presentation. If you'd like to know more, take a look at our help files. It's also available in Korean. I think it's a very interesting topic. Thank you.